Okay, we are working on some more problems from lesson 6.4. Factoring polynomials. So the next polynomial that in fourth period we need to factor is number 4. So some of the classes got beyond number 4, but several classes just got through number 3. So I'll start with number 4 and do through number 11. So for number 4, they gave us 3 terms again. And we will look for the greatest common factor. In this case, the greatest common factor is x. And if you divide an x out of all 3 terms, you end up with a trinomial, x squared plus 9x plus 20. So the next step is to see a factoring pattern. Well, since 20 is not a perfect square, I realize this is just a common trinomial where I ask myself, factors of 20, when added, give me 9. So 1 and 20 don't add up to 9. 2 and 10 don't add up to 9. 3 doesn't go into 20. 4 and 5, those two add up to 9. So my final step is to write my factored polynomial. Don't forget your x factor that you took out at the very beginning as the greatest common factor. And then the square root of x squared is x, and plus 4 is positive, and x plus 5. And you're done. Okay, that is number 4. Let's see if I can get this moved. Okay. No, I got my picture. Okay, touch and hold in. Let's see if I can get this page moved. There's my new page. Okay, number 5. It says factor the polynomial or identify it as irreducible or prime. If the polynomial is irreducible, enter NA. So I look at my polynomial. This is number 5. Uh, 64 x cubed plus 729. So these look familiar, and if you remember our list of perfect cubes, that is 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1,000. So there's the 64. That is 4 cubed. And there's the 729. Whoops, that's not a very good cube. 9 cubed. So when I see these are both perfect cubes, 64x cubed is perfect cube. It is 4x that has been cubed. 729 is a perfect cube, so that is 9 cubed. So that pattern fits the pattern called the sum of cubes. Since these are perfect cubes and they're added together, this pattern is called the sum of cubes. If you notice at the very beginning, obviously 64 and 29 have nothing in common. Because 4 and 9 have nothing in common, 2 and 3 have nothing in common, so there's no greatest common factor. So we go right to the pattern, and we rewrite the pattern. The pattern says I take the cube root of 64x cubed, which is just 4x, and the cube root of 729, which is just 9. That's your first factor, those two terms. Now we take the term we found as the cube root and square it, because these two multiplied together need to come up with the product of 64x cubed. And then we have since there's a plus at the beginning, this guy comes from the relationship between those two. You have to have a negative somewhere, so when you go to distribute again to get your final product that ends up just being two terms, you have to have a negative in there, so some of the terms add up to 0. So that's where the negative lives, is on the next term, which is the product of 4x and 9. And remember, I'm just getting this from page 131 of our planner that has all the patterns. They don't have them named there, but they're pretty obvious what they are. So know that page 131 is where you'll find the patterns for factoring. Okay, the last term here in this factoring of sum of cubes is the second term squared, which is 81. Now the fact this isn't doubled, that 36 is just 4 times 9, 4x times 9, we didn't take it times 2. This is done being factored. There's no more factoring, no more nothing. You're done, done, done. With number 5. See if I can get a highlighter. This is what you'd enter into your, ooh, that's not very thick. Let's see if I can make it. There we go. This is the, don't forget the parentheses, what you'd put in your solution. Okay, number 6. Oops, I need to be out of my yellow. Need to go back to black. This is just a binomial. 3x cubed plus 6x. There is a greatest common factor of a number 3 can go both terms, and an x can go into both terms. So I'll write that greatest common factor out front. And I could see if I divide this by a 3x, the 3's cancel and all I get is x squared. Divide this by 3x, the 3 goes into 6 twice and the x's cancel. Now we look for this pattern. This is a perfect square, but this is not. So, and there's no sum of squares in the pattern. There's only differences. The fact that's an addition makes that a no-no as well. So you are done. Factoring number 6. Okay, I can probably get number 7 on this same page. You look at 64x cubed minus 512. First of all, we've got to see if they have any greatest common factor. So I think of 64 as being, 8 and 8, which is 2 and 4. 2 and 4, so it's all 2's, 6 2's, and then 512. There's at least one 2 in 512, I know that. I think 512 was 8 cubed. So this was 8 times 8 times 8. So 64 could probably go into 512. So I'm just playing with the numbers, seeing what they have the most of. And you want to get the biggest, remember it's called the greatest common factor. Between 64 and 512 should be 64. So, and they don't have a cube relationship, x relationship, so that there's no variable. So we take the 64 out. And all this leaves inside is x cubed minus 8. Because 64 times 8 is 512. And you'll have to practice that. You have to practice to get good at the number sense again. It's been a while since we've had to crunch the numbers. So rise to the challenge. All right, that's my GCF. Got that taken up. Next step, see a pattern. This is a perfect cube. That's a perfect cube. So what we're going to factor is x cubed minus 2 cubed. So here we go. The 64 is the greatest common factor that was taken out. Cube root of x cubed is x. We take the sign that's between the two. Cube root of 2 cubed is 2. And then we play the pattern game for the difference of cubes. So this next term gets that subtraction here. I don't use a subtraction sign anywhere else in the pattern. Get x squared, so these two multiply to x cubed, you know that's right. I have to multiply 2 times x. And the reason that is, when you go distributing everything, those middle terms fall away. All you have left is the 64x cubed minus 512 when you distribute this all back out. And then this one is 2 squared. And you're done with number 7. So that was fun. The fact there was such a great big greatest common factor. Isn't that interesting? That 64 came out of both. So don't forget him though when you're going to write your answer, right? He's a part of the game too. Okay. Number 8. Get my black color up again. We haven't had a non-factorable one for a while. It says factor the polynomial or identify it as irreducible. If the polynomial is irreducible, enter NA. So we start out with 100x cubed minus 6400. So the greatest common factor I spy with my educated eye is 100. No x's. So if I factor out 100, that leaves x cubed minus 64. Perfect cube, perfect cube. Difference of cubes, 100. Let me see, this is 4 cubed, right? So it's x minus 4. You take the cube root of x cubed, which is x. Take the sign of that's in between, which is a subtraction, and the cube root of 64, which is 4. Square the first term. Done with the subtraction, so everything's plus. Multiply the 2, and square the last term. And then you're done with number 8. Don't forget your greatest common factor. Okay, number 9, factor the polynomial. So the instructions are the same, but we don't want to take them for granted because it might be irreducible, and if the polynomial is irreducible, you enter NA. So number 9's polynomial, unique and wonderful. 2x to the 4th plus 9x to the 3rd plus 7x squared. So, look for a GCF, which is x squared. You can't take a x to the 4th out of all of them because these have less numbers of x's, factors of x. This has 3, but this one doesn't, so you have to take 2. This has two factors of x, this has two factors of x, and that has two factors of x. So x squared comes out, and we have 2x squared is left, plus 9x plus 7 alone. All right. Now, this is not a perfect square, not a perfect square. Neither one of them are perfect squares, but that doesn't mean they're not factorable. They have a leading coefficient other than 1, so you're going to use the bottoms up method to find factors, if possible. Again, so here's how we play the bottoms up game. You pretend that 2x squared plus 9x plus 7 is, you take the first coefficient and you multiply it to the last term, so you're having a pretend polynomial you're going to factor. Then we'll undo this game, so then it'll be real again. Right now, this is a pseudo polynomial we're factoring, and that's the common factor. Factors of 14 when added give me 9. So this guy factors into x plus 2 times x plus 7. Now here's where the bottoms up happens again. See if I can move this down. We moved the 2 over to the 7. Now we're going to move it back up again by taking and dividing what we moved, both of those factors, by 2 again, and reducing. So this one is x plus 1. That's a factor for reals. And this one, because 2 doesn't go into 7 evenly, you put the 2 next to the x. You just reduce that as much as you can. It's already reduced. Plus 7 is your other factor. Don't forget this guy. He is still a part of the solution when you're factoring polynomials. So that was fun and done. And it is so amazing because, oh, I remember the hours spent. And it was fun for me because I love math, but this just saves time, and you're right every time, because you just use the common trinomial method of factoring, and then you go back and create your factors. That was number 9. Good times. 2 left. So, we've seen some of them, not all of them. Hopefully, by the time we're all done with this lesson, you'll see most of the methods of factoring polynomials. Even though you never run out of polynomials to factor. They're all unique and wonderful. Hopefully you see the light. How do we come up with a greatest common factor? What do they all have in common? Then you can mental math, divide out an x, get x squared left. Divide an x squared by x, you have an x. And divide a negative 42x by x, you get a negative 42. Now it looks like a common trinomial because it's a negative 42. The negative with the number. And they're going to add up to 1. So it's a negative 1 and 42, negative 2 and 21, negative 3 goes, and 14. Negative 4 doesn't go, negative 5 doesn't go, negative 6 goes, and a 7. Oh, look at there. Those two equal If you take negative 6 plus 7 equals 1, you got the two factors. So you write your polynomial x, parenthesis x minus 6, parenthesis x plus 7. Remember, the order of the factors don't matter. They just like this lone factor in front. That's just nice to have. And one more, and I'll leave you alone for the day. And see you tomorrow. And number 11. It says factor by grouping. Ooh, we haven't done this one yet. This is fun. Grouping, grouping, grouping. Why do we use grouping? Well, we're in the land of Oz, and they give you 4 terms. When you group them into 2 terms each, and sometimes you have to rearrange them and sometimes you don't. I'll let you know if you do. But I think they have you set up for success. Grouping, you see this, these first two terms we factor, a greatest common factor out. These second 2 terms we see if there's, that 18 is pretty ugly. Let me make that a better 18. There we go. Okay. Then we factor whatever's in common in those 2, and then you'll see another pattern emerge out, so we can factor some more. For greatest common factor, greatest common factor, greatest common factor. This grouping uses greatest common factor repeatedly. So I see an x squared in both of these. So I have x plus 6. Okay. And I see a 3 in both of these. So I write my 3 because it's positive, and that leaves me an x plus 6. Now we go one step further. These 2 terms have a greatest common factor of x plus 6. So when I take those 2 out, that leaves me an x squared plus 3. Now you can't factor x plus 6 anymore, and you will never have a sum of squares, so you are done. And that was a bunch of fun. And please keep up on this assignment so it doesn't overwhelm you and you have to do it all at once till 2 o'clock in the morning and midnight of December 16th or whatever. So be sure and pace yourself, and we'll see you tomorrow.